Hi, good morning, everyone. Thank you for participating in this meeting. I'm Wataru Takahama from the Ministry of Economy, Trade and Industry. So today's event is organized by RIGHT and EASA. As for RIGHT, through the scenario study and analyzing data, RIGHT contributes to the discussion towards net zero society, not only in Japan, but also in the world. In addition, edits, which is going to explain later, RIGHT together with ESA, contribute to develop the international community about low energy demand. As for the demand, it is really important. We Japan fully understand it. However, the discussion so far, for example, G7, G20, COP, the focus of the discussion is mainly on the supply side. For example, how to expand the renewable energy, how to reduce the coal power plants. However, the situation is now changing. Since last year, for example, FMC, Fast Mover Coalition, which facilitates the net zero technology from the demand side, and IDDI and net zero government, which is going to launch, I think today, which facilitates the public demand. And India's initiative, LIFE. The discussion is now changing. The focus is now changing from supply side, not only supply side, but also demand side. So I expect today's organizer, RIGHT and EASA, to contribute to the international discussion. Finally, I would like to share the one word. Data always win. This is a word from the Dr. Fatih Birol, IEA Executive Director, who made at the Global GX conference in Japan 2 months ago. I'm very much looking forward to today's discussion. Thank you very much.
Thank you very much, Mr. Wataru Takahama, for your very encouraging and very pertinent comments. And I would invite now the first panel speaker, Dr. Keigo Achimoto, who is the leader of the System Analysis Group and the chief researcher at RIGHT. He has been a lead author for the 5th and 6th assessment report of IPCC. His scientific interests are in modeling and analysis of energy and environment systems. He is a member for several advisory bodies on energy and environmental policy for the Japanese government. He will give an overview of the EDIT project and also share some of the very, very interesting results. Yes, Akimoto-san.
Thank you very much, Joshua, and thank you very much for all of the participants in this room and also from online. So let's start. I'm sorry. Wait a moment. Yes. Okay. Again, thank you very much for all of you. I would like to talk about the background of the energy demand changes induced by technological and social innovation, EDITS network, and I'd like to, so let's start. This is the G20 Karuizawa Innovation Action Plan on energy. Sorry. I'm sorry, waiting. Yeah, okay. Uh, uh, Innovation Action Plan on Energy Transitions on Global Environment for Sustainable Growth in 2019. G20 states, we recognize the importance of quantitative analysis on better understanding future energy demand and supply, and the role of innovation of both sides driven by digitalization, AI, IoT, and the sharing economy. We encourage efforts made by the global scientific community and international organizations and frameworks to further define and develop the full spectrum of economy-wide scenarios for energy and climate models. So, yeah. Okay. Okay. So we start edit project. Energy demands changes induced by technological and social innovations. This project is supported by METI. So participating research institute or researchers include EASA, AIT, LBNL, OECD, ITF, CMCC, and many of the international institute and researchers. So nearly 100 researchers, including mainly IPCC lead authors, have been involved. The objectives are as follows: to create a research community with a focus on end use, demand side perspectives, and further dialogue and cross-fertilization of research and policy analysis through the sharing of novel data, novel concepts, methodologies, and policy analysis. To improve the state of the art of demand modeling in environmental and climate policy analysis via methods and model intercomparisons as assisting the transfer of conceptual and methodological improvements across disciplines, sectors, and environmental domains. To better inform policy via structured model experiments and simulations that assess potential impacts, barriers, as well as synergies and trade-offs to other SDGs objectives of demand-side policy interventions, particularly in novel fields and service provision models such as digitalization, sharing economy, or the integration of SDGs and climate objectives in synthetic policy designs. So this is the whole picture of the response measure to climate change. Not only energy supply side, but also CDR technologies and energy demand side is very important. But existing studies particularly focusing on energy supply side, but also energy demand side is very important. And so it's project focusing on mainly on the energy demand side, including behavior changes. Oh, sorry. This is a picture of the low energy demand scenarios reported by the IPCC special report on 1.5. This is a typical 4 scenarios. P1 scenario is namely LED scenario, low energy demand scenarios. These scenarios, the contribution of CDR is very small in this scenario. And also IPCC, the 6th assessment report also shows several kinds of carbon neutral measures, including low demand scenarios, as you can see here. In this scenario, there are no bioenergy with CCS and direct air capture with CCS options. So due to the very low energy demand societies. So, and low energy demand scenarios contributes multiple SDGs. So this is a concept. So deep emission reductions at affordable cost will be one of the keys to achieve multiple SDGs, and the digitalization and the related other innovations will contribute to the achievement of SDGs. So this is another figures according to the IPCC AR5. For example, digitalization impact is very huge to reduce energy consumptions and also CO2 emission reductions, as you can see here. Left-hand side shows several kinds of digitalization technologies and the impact on the energy consumptions and also GHG emission reductions. And also right-hand side here shows the sharing economy and the circular economy impact on the energy demand and GHG emissions. Of course, currently there are huge uncertainty of the estimations, but large potentials can be estimated according to the IPCC. Oh, yeah. But there are several knowledge gaps on the energy demand. So first, a better metric to measure actual human well-being. Second, evaluation of climate implication of digital economy. Third, scenario modeling of services. And fourth, dynamic interactions between individual, social, and structural drivers of change. These gaps will also be tackled within the EDITS project. So we are now developing narrative scenarios and also quantitative scenarios. This is the narrative concepts, high with low scenario. This means high well-being with low resource usage. I'd like to skip the explanation of this concept, but next speaker will explain the details. So I will skip, but how can we approach this scenario from a modeling side? I'm a expert for the integrated assessment model. So next, I'd like to show you preliminary scenarios based on this concept scenario, high with low scenarios. So this is the overview of our integrated assessment model, DNA21 plus. But I would like to explain, I would like to skip this model explanations, but this model is very detailed, treated in the technologies, not only energy supply side, but also in energy demand side. So 500 technologies are taken into account in this model explicitly. So this is the scenario assumption, but this is very preliminary so far. But today I would like to show you some scenarios. So now we consider following several digitalization technologies. First, ride and car sharing associated with fully autonomous cars. Second, virtual meeting and teleworking. Third, e-publication. Fourth, recycling and reduction in apparel due to e-commerce and other digitalization technologies. So fifth, longer lifetime of buildings due to improvement in city planning. Sixth, reduction in food losses due to better demand projection. Seventh, 3D printing for applying aircraft. Eighth, reductions in flight shipping services due to the reductions in basic materials and products. So this, I would like to show you the quantitative scenarios by using the DNA21 plus model. I would like to show you some scenarios. First, baseline scenarios, which is not considered, do not consider specific climate policies. But and also we consider B2DS scenarios, that is well below 2 degrees scenarios, and also carbon neutral by 2050 in G7 countries. And we have several digitalization innovation in end use sectors, as I already explained the previous slides. So this is the preliminary results of final energy consumptions in baseline scenarios without additional climate policy scenarios. In 2030, 2040, and 2050. This is just only a baseline scenarios. That means without carbon prices. But we can see the large energy, final energy reductions can be seen, as you can see here. While this preliminary study assumes only limited impacts of circular and sharing economies due to digitalization, mainly significant reductions, that means by around 10% in final energy consumptions are estimated by using this model. And next figure shows the GHG emissions. This is also in the baseline scenarios without additional climate policies. But we can see the large reductions in GHG emissions. The assumed digitalization impact in end-use sectors on entire GHG emissions are estimated to reduce the emissions by around 7%. And those plus the assumptions on rapid cost reductions in granular technologies. Granular technologies are mainly introduced in end-use sectors, and also demand flexibility in electricity demand flexibility could reduce the emissions by around 20%, even if limited factors are considered. So this is a final energy consumption in B2DS scenarios. You can see the white area shows energy saving induced by carbon prices for B2DS scenarios. But also you can see the additional reductions in final energy due to the digitalization innovations, particularly through sharing economy, circular economy, and so on. So final energy consumptions will be reduced by around 25% in B2DS with cheaper carbon prices, thanks to the impacts of end-use technological and social innovations. Next, this is the GHG emissions for B2DS. You can see the dependency on carbon dioxide removal options will be reduced due to the reductions in carbon prices, thanks to the digitalization impact in the end-use sectors. So also we can see the final energy consumption per capita by region. For OECD countries, final energy consumption per capita will greatly reduce due to this impact. But for developing countries, almost same or greatly increase. So the high with low scenarios induce smaller difference in final energy consumption across region. So final figure shows changes in emission reduction costs. You can see here the emission reduction costs can be reduced greatly through the assumed innovations in end-use sectors, and the affordable cost measures will also help increase in feasibility and achieve multiple SDGs. Finally, I would like to conclude as follows. EDIT project is developing comprehensive and quantitative scenarios of narrative high with low scenarios. That means the high well-being with low resource use with DNV21 plus model and other several models participated in the other institute. And digitalization and the related innovations could induce rapid changes in our society, reduce several resources and embedded energy consumptions through circular and sharing economy and achieve cheaper cost of deep emission reduction. Our edits project members believe that better understanding on the potential changes and great contributions to emission reductions, as well as achievements of multiple SDGs through comprehensive analysis, will induce the movements in all people, including consumers, industry people, and policymakers. Thank you very much for your kind attention. Thank you.